Let's sketch what these integers look like on this number line. Between these two consecutive perfect squares, we're going to squeeze in some numbers. Somewhere after x squared is going to be our multiple of 1,000, 1,000 times n, and then we're going to have 1,000 consecutive integers, and then after that, we'll have our next perfect square. Let's ignore this multiple of 1,000 restriction first, and we'll find the lower bound on the length of the interval between these two consecutive perfect squares. We need to squeeze in at least 1,000 consecutive integers between x squared and x plus 1 squared. So if we subtract these two, we need this to be greater than or equal to 1,001. If you FOIL this out and subtract x squared, you're left with 2x plus 1. So x is greater than or equal to 500. Since we want to minimize n, means we're also going to minimize x. Let's let x be equal to 500 plus a, where a is non-negative. Since we want these two perfect squares to straddle a multiple of 1,000, this means we want our first perfect square to be less than or equivalent to 999 in mod 1,000, and we want the next perfect square to be greater than or equivalent to 1 in mod 1,000. That means the multiple of 1,000 is going to be between these two perfect squares. Let's square this x in terms of a. This is a multiple of 1,000, and this is a multiple of 1,000. So this expression is equivalent to a squared in mod 1,000. Again, we're trying to pick two perfect squares on either side of a multiple of 1,000. If we take a is equal to 31, then a squared is just to the left of a multiple of 1,000. When a is equal to 32, we get a number that's just to the right of a multiple of 1,000. Adding these to 500, we get the same result for 531 squared and 532 squared. So we must have a multiple of 1,000 between these two perfect squares. Let's check to make sure that all 1,000 consecutive integers, starting with this multiple of 1,000, are in this interval. We'll use this formula. So when a is equal to 31, we get a perfect square that's just to the left of 282,000. When a is equal to 32, our next perfect square is the square of 532. This is going to be over 283,000. So on our number line, here we have 531 squared. We have our multiple of 1,000 here. We have another multiple of 1,000. That's 283,000. If we subtract 1, this gives us our 1,000 consecutive integers, and we have our next perfect square up here. This means n is equal to 282. If you'd like me to solve any other math contest problems, please leave them in the comments.